In this video, we're going to talk about work and energy. And so previously we've talked about how to calculate work, right? We can give a number to it, but we haven't actually talked about like what it is, right? So in this video, we'll talk about what work actually is. So work is the transfer of energy by a force acting over a distance. So when you think about work, I want you to think about a transfer. I want you to think about what is transferring energy to what, because that's what work is. And now the natural question is, well, what is energy, right? So my definition for energy is pretty lame, but it's energy is the ability to do work. So if work is the transfer of energy by a force over a distance, and energy is the ability to do work, it makes sense that the units of energy would be the units of work. So the units of energy are also joules. And that should make sense. Think about that a little bit, let it marinate. So one important thing about energy is that it is conserved. So energy is conserved. And that means that it can be neither created nor destroyed. Which means there's really like a set amount, right? So work means you can transfer it from one thing to another thing or from multiple things to one thing. But if it's transferred, they must give up their energy to transfer it to something else, right? You can't just magically create energy. You can't magically receive it. It's got to come from somewhere, and there's a set amount. So let's think about two tangible examples to kind of let it sink in. So say I'm in outer space, right? And this is just to kind of avoid friction, and maybe later on we'll see why friction would make this more difficult. But say we have a ball, and this ball is just traveling at a certain velocity, moving through space, right? And then say there's this other ball here, and this ball's at rest. So this one's moving, this one's at rest. So the one that's moving, right, I'm going to tell you has energy, right? It has the ability to do work. And you're just like, well, what do you mean? Well, this one that's moving, right, it could hit this one that's at rest. And when it does that, it could apply a force to that other ball. So if they're ball A and ball B, if ball A is moving and ball B is not, ball A could apply a force on ball B when they collide over a small distance, right? And what we would see would be that kind of ball A would slow down. Ball A would slow down a little bit, but now ball B would be moving. You can think about this as like kind of like pool maybe, right? So we have one that's moving and one's at rest. They collide, and now they're both moving. But A is moving with a little less velocity than before, but now B is moving with a velocity. So let's think about this. So ball A, because it's moving, can apply a force, right? Ball B cannot apply a force right now to something else, not at least from a collision, right? So ball A has energy because it's moving. When ball A hits ball B, it does work on ball B, right? A force is transferred from A, a force is applied from A to B over a distance. I don't know why I wrote a G here for the force. That's wrong. Right, so then ball A did work on ball B, which means ball A transferred energy to ball B. So now that ball A collided with ball B, it's not moving as fast now, right? It has less energy, right? It can do less work now, right? If there were a long row of balls, and ball A kept colliding with other ones, like eventually it could come to a stop, right? And the more work it does, the more energy it transfers, and eventually when it comes to a stop, it's transferred all of its energy. And you can see that transfer because now the other balls have a velocity, so now they can do work, and they have more ability to do work.